So let's do the next problem. All right. So for the next problem, we're gonna do the length of a human.
Sorry, what was D?
Part C was greater. So the probability in part C was greater.
Okay.
So let's do this next problem. So for the next problem, it says the length of a human pregnancy is right-skewed distributed with an average pregnancy length of 266 days and a standard deviation of 16 days. So for right here, they give me three things. So the first thing that they give me is the average. So they tell me the average length of a pregnancy is 266 days. The standard deviation of a pregnancy will be 16 days. And they also tell me the distribution of this data set. So if you look at it, they tell me that this has a right skew distribution. All right. So those are the three important information that the problem gives us. So they tell us the mean length of a pregnancy is 266 days. They're telling us the average standard deviation for those 16 pregnancy is 16 days. And that the distribution is a right skew distribution. Any question on where do those three information come from? All right, so let's do part A. So for part A, it says for this problem, do we need to apply the central limit there? So if you kind of remember for the central limit there, we only apply if A, I don't know the distribution, or B, if the distribution is not a normal distribution. So if you look at this case, they tell us it's a right skew distribution, which is not a normal distribution. So we'll say, yes, the central limit theorem need to be applied since our distribution is right here. So for this one, we actually do need to apply the central limit theorem because our data set is right skewed. Oops. Apply. Thank you. Yeah, so for this one, we do need to apply the central limit theorem because our data set is right skewed. If you look at the last one we put that we didn't need to apply because our distribution was already normal. So if our distribution is already normal, there's no need for us to pretty much apply. But in this case, since we know our distribution is right skewed, so we do need to apply the central limit theorem. All right. Everybody good for part A? All right, let's do part B. So for part B, it says, what is the probability a randomly selected pregnancy lasts more than 260 days? So for part B, what is my sample size?
One.
Yeah, 1. So n is equal to 1. Because it said a randomly selected pregnancy. So that's telling me we're only selecting one pregnancy. All right. So for this one, since I know our distribution is a right skew distribution, we need to apply the central limit theorem. So to be able to apply the central limit theorem and say that our distribution is approximately normal, it has to pass the case where n has to be bigger than or equal to 30. So for this one, does it pass that condition? Well, if our sample size is n is equal to 1, 1 is actually less than 30. So this condition Well, it didn't pass the condition. So that why for part B, you would put, we cannot find the probability for a right skew distribution. And that'll be it for part B.
Sorry, where did 30 come from?
So 30 came from the lecture that we went over on Wednesday. So for central limit theorem, so the CLT, so for the central limit theorem, it said that if our sample size is big enough, we could say that the new distribution that we're pretty much getting should be approximately normal. So usually the rule of thumb for the central limit theorem is that n has to be greater than or equal to 30. So that's how we consider if something is big enough. So if something has a sample size bigger than or equal to 30, we're gonna say it is big enough, and we're gonna say that the new distribution is approximately normal. So that's why we're referring to 30. It is going back to that condition.
Got it. Thank you.
Yeah, you're welcome.
Professor?
Yeah.
I wanted to ask, this is a little off topic, but how many tests do we have before the final?
Most likely should be 2 more.
Okay, because I just wanted to see if I have like a chance to raise my grade.
Yeah, there's 2 more tests.
Okay. And another thing is, for the test corrections, do they help like a great amount or they just help like a little bit?
No, they should help for the grade amount. If you got like a 40%, theoretically, if you get everything correct, you could bump it up to a 70%. So yeah, it does help a lot.
Oh wow. Okay, so if my test corrections are correct, can like bump up a 40 to passing.
Yep.
Wow. Okay.
All right, so let's get to part C. So for part C, it says suppose a random sample of 50 pregnancy is obtained. Describe the sampling distribution of the sample mean length of a human pregnancy. So this is kind of what we went over on Wednesday. So if you weren't here on Wednesday, well, this is a good kind of little refresher on what we went over on Wednesday. So for this one, they tell us we have 50 pregnancy. So the 50 pregnancy represent our n. So n is 50. So if you look at this one, it said describe the sampling distribution. So if we want to describe the sampling distribution, there are usually 3 things we want to give. We want to give what mu of x bar is equal to. You want to give what sigma of x bar is equal to. And mu of x bar is equal to mu. Sigma of x bar is equal to sigma divided by square root of n. And you want to tell me if the distribution is normal, is it not normal, or can we say is approximately normal? And to be able to say it's approximately normal, that's where the CLT will be used. If it's normal, the problem should state it's normal. All right, so let's go ahead and do this one. So first we're gonna go ahead and find mu of x bar. So mu of x bar is equal to mu. So if you look at it, since it's part C, that means we're gonna use the information from the beginning, because all of that is referring back to the information that was given to us. So if you look at it, mu is equal to 266. So I'll put 266 over here. Any question for the 266? So up next we want to do sigma of square root of n. So sigma is 16 days. N is 50 days. So if I do 16 divided by square root of 50, so like 16 divided square root of 50, you get 2.26. Yeah, 26. Any question? I got the 2.26. All right. What was that? Okay. All right. So up next, we're gonna go ahead and go ahead and try to figure out if this is a normal problem, a normal distribution, if it's not a normal distribution, or if this is approximately normal. So in order for it to be a normal distribution, the problem had to tell us that this is a normal distribution. So if we actually go back to the beginning of the problem, if you look at it, they actually told us that this was a right skew distribution. So we're definitely not going to say it's normal. So up next, we're either going to say it's not normal or it's approximately normal. So in order for it to be approximately normal, it has to pass the condition of the central limit theorem. So remember, the condition for the central limit theorem said that n has to be bigger than or equal to 30. If it's less than 30, then we're going to say it's not normal. So in this problem, we're going to get n, which is 50. And if you look at 50, 50 is indeed bigger than or equal to 30. So since that condition passed, we say our distribution is approximately normal. And we'll cross that one out. All right, so that's kind of a little refresher on what we did on Wednesday. Any questions so far? Why say mu of x bar equal to 266, sigma of x bar equal to 2.26, and why the distribution is approximately normal?
So for this one, we didn't need to figure out like 2.26 as the sigma.
No, well, for this one, you do need to figure out that the 2.26 is the sigma. Because to be able to find sigma of x bar is always equal to sigma divided by square root of n. So you do need to figure the 2.26 out. Because anytime it says describe the sampling distribution, you want to get mu of x bar, sigma of x bar, and also the distribution.
It was that describe part that I was missing. Okay.
Correct. The describe part, pretty much those are the three things that you want to describe. All right. Any question in regard to C? All right. So let's do D. So if you look at D, it says, all right, let me stop sharing because stop sharing. So all right, so let's do part D. So for part D, says what is the probability that a random sample of 50 pregnancy has a mean pregnancy period lasts more than 260 days? So let's go ahead and find part D. All right, so if you look at the mean is 266, so that goes in the middle. If you look at the 260, that's smaller than 266, so that means it goes to the left of 266. If you look at it, we want the pregnancy to last more than 260 days, so that means you want to say the right-hand side. Any questions so far on my drawing? All right, so if you look at the drawing, just based off of the drawing, your answer should be bigger than 50%. Because if you look at it, you have more than half of that distribution shaded. So any answer that you get, you should kind of already have an idea that it should be more than 50%. So let's go ahead and figure out what the lower bound, upper bound, so on and so forth is. So let's do the lower bound, upper bound, oops, mu, and sigma is. So if you look at mu is still 266 days. If you look at our sigma, since we're doing this for a pregnancy of 50, our sigma should be 2.26, not the 16, because you want to adjust it for taking a random sample of 50, not taking a random sample of 1. Any question for mu and sigma? All right, so up and we're going to do the lower bound. So for the lower bound, if you look at it, is 260 days. So we'll put lower bound is 260 days. If you look at the upper bound, it doesn't get cut off or it doesn't have an end inside. So for this one, since theoretically keep on going to the right-hand side, we're gonna say it keep on going all the way to positive infinity. So for this one, you say positive infinity, which is 10 to the 10 power. Any question on lower bound is 260, upper bound is infinity, mu is 266, and sigma 2.26. All right, so I'm gonna go ahead and transition over to my TI-84, and I'm gonna work this out. So we'll say second bars. I'll put number 2 to select normal CDF. So for this one, we want to put the lower bound. The lower bound we said was 260. We said the upper bound was 10 to the 10 power, so I can actually just leave that as is. Mu is 266. And lastly, sigma is 2.26.
So even though this wasn't a normal distribution, we still use the normal CDF function.
Correct. So the reason why we're using the normal CDF, because it passed the central limit theorem test.
Got it.
If it wouldn't have passed the central limit theorem, if you kind of notice on what we did for for part B, since for part B it didn't pass the central limit theorem, that it didn't have a big enough sample size. For that one, you just can't find the probability. But if your sample size is bigger than or equal to 30, then you can just say it's approximately normal, and you can actually go ahead and continue finding the probability for this one.
Got it. Yeah, I thought we might be using, there are so many CDF options under distribution, so I wasn't sure if we were going to use a different one.
No, pretty much you're just using the same one. All right, so then you go over here to paste, and we're done. So we'll say the probability of pregnancy of 50, well, the probability of pregnancy of 50 pregnancy lasts more than 260 days is equal to 0.996. So there's a pretty good chance that pregnancy will last more than 260 days. And that's it for that one. Any question in regard to that last problem? And then this is how you will write it. So let's go ahead and let's just scroll on down.